On this episode, there's more scooter learning, and the Internet of Things is rolling trillies, not billies. Hey everybody, welcome to episode 13 of Daily IoT. I feel like we're getting a pretty decent rhythm this week. I'm trying to film as much as possible. It's a lot of work editing these things. It takes me longer than I would like it to, but I love getting the content out and I love hearing from you guys. I want to step into just a couple of items of news. One's not really news. I've been playing around with the particle photon, like I said, been doing a lot with that. I was messing around with updating firmware to pre-release versions and stumbled upon a new logging feature that's coming out in the next release of their firmware, and ended up putting a video together of how to update to a pre-release version of the firmware. I'll link that up here if you're doing particle stuff. It's just a quick how-to microcast that I put together. Another piece of news was an article I saw from Read Write a couple of days ago where they talked about the reach and impact of the Internet of Things. And this came out of a report from Cisco. I want to make sure I get the number right. I'm going to lean off screen here. I should have looked at this before, but I didn't. Cisco did a report talking about the impact of the industry of Internet of Things, and Cisco CEO John Chambers figures that by 2020, Internet of Things will be a 14 trillion, not billion, trillion-dollar industry. Now, these numbers are so, this is like any news thing where it's like, oh, the Internet of Things is going to be like $5 trillion, $10 trillion, $100 trillion. And, so there's lots of different numbers that people are throwing out for what the industry value of Internet of Things will be in 10 years, 20 years, 30 years. But the point and the reason why I wanted to share this was, and I'll link it up below so you can read it, is that the Internet of Things wave is coming, and it's already coming. Like, those that are following tech see it, and it's commonplace, but still, and I always remind people of this, if you go out and ask 10 random people on the street at the grocery store if they know what Internet of Things is, my experience is 9 of them are going to say, I have no idea what you're talking about. And so many people still don't know what the Internet of Things is, but the wave is coming. And, even though they don't know what it is, a lot of them are users of it. Lots of people have Nests or other devices that would be considered Internet of Things. But the point is, the industry is only growing. All these articles about IoT is dying, the products suck, and it's all nonsense. The Internet of Things is going to continue to expand. And so if you're interested in getting into it, I think personally it's a great career opportunity. If you're young, it's something that you can't go wrong. And if you have some sort of specialty, and the beautiful part about this is there's so many different areas to Internet of Things. This is not just hardware, it's not just software, it's data analysis. We're gonna need project managers coming out of our ears to manage all the projects that are gonna happen in Internet of Things. So lots of opportunity. If you wanna specialize a little bit, play around with it. I think there's just so much opportunity getting in an Internet of Things going forward, beyond just personal fun. If you just like to do it for personal enjoyment and a hobby, awesome. If you want to make it more of a full-time thing and career move, I think it's a great opportunity. So I'll link that article up. Just more news coming out about how big Internet of Things is getting and is going to get. So last part of today's episode is a scooter update. Got that project going with Matt at work, and so I'm going to switch to some work footage that we shot today. And I apologize, the lighting at work sucks. The audio isn't as good. I don't have mics from both Matt and I, so bear with us. I feel like the content's good. We talk about the progress on the scooter and some of the learnings that apply there. And so let's switch on over to the work footage. All right, so last time we talked about how we had all these controls that we used to drive the scooter with, and how they run through a wire harness down underneath the seat to the main control board. And we used a meter to trace the wires from the controls down to the end of the harness so that we could tap into those at a later point. However, what we didn't talk a lot about is the controls that are up there and how we will talk to those and get information from them. So wanted to go back, pause, do that really quick and talk about this, because this is a real practical application of things that you've probably heard about before in other getting started activities, but maybe didn't make the connection in your head. And so we've got our fancy whiteboard version of the control panel here, and it's got the fuel gauge that tells you what the battery looks like. It's got a turtle rabbit mode knob that you can turn to determine what your max speed is, whether it's a slower pace or a faster pace. It's got a key, and then it's got the red dot down there is a buzzer or a horn. Love it. And then on the sides, you've got these little handles that you push down forward or backwards to control your throttle, how fast you're going. And so there's a couple of things going on here that are just super simple electronics principles that we can cover really quick so that you know how to recognize these things in the wild and communicate with them. And so what I want to talk about really quick is a concept, it's a part called a potentiometer. Now, I think if you've gone through like an Arduino setup or even like the particle photon stuff, you'll have done a project that had a potentiometer. It's like a little knob, you put it on the breadboard, they normally have 3 pins, and the projects are normally like you turn them and you make an LED flash faster or slower or be brighter or more dim. But what you may have thought is, okay, I've got this potentiometer thing, but what is that in the real world? And so if we look at our control panel here, we have 2 potentiometers. One is the rabbit turtle mode, where you can turn this through to control the max speed, and the other potentiometer is the actual throttle control, forward and backward. And those 2 things control the speed of the electric motor on our scooter. And so the principle in action here is very simple. What we're going to be talking about, and Matt's going to talk a little bit more about it, is general purpose input and output, GPIO. And so a potentiometer feeds into this. I'm going to just draw the equivalent circuit here. It's really just 2 resistors. And the way this works is you have a voltage that comes in. You'll normally attach the top part to your positive voltage, the bottom part to ground, and then inside there's this thing called a wiper that moves across. You don't need to know what the physics are of it, but basically it creates a variable resistance. The resistance between these 2 points and these 2 points will change based on how you turn the knob. And that's useful because of a principle called voltage division. And I will link it up. I don't want to get into it. I'm not going to go into an in-depth conversation on what that is. But basically it means that if we put a voltage in at this end, by turning the knob, we can control the voltage that comes out between the high voltage and 0. So you turn that potentiometer and it makes that voltage swing, and then we can read that voltage on our platform to say the knob is turned this way or that way. And so we can translate that. And so that's the basic concept here. And so I said we have 2 of them. They both don't run down to the wiring harness. One of them runs into the other. So we're sort of chaining potentiometers to create an overall scale of our system voltage, which in the case of our scooter is 24 volts. And so that was kind of fast. And if you didn't understand all of that, don't worry about it. We're gonna keep covering these things. But if you do have questions, stick them down below. We can answer those. But that's sort of the basic idea with using potentiometers in a real-world application, using knobs. Anytime you see a knob on a piece of electronics, it's almost always a potentiometer. Sometimes there's digital versions, but a lot of equipment, it'll just be an old analog potentiometer, which is just a variable resistor. And so go ahead and turn the time over to Matt really quick, who's going to talk about the other GPIO stuff that we have going on our control board.
What I'm going to cover a little bit more now is GPIO, that is General Purpose Input and Output. So there on most boards, if you've worked with these hardware boards before, there's going to be a row of pins somewhere that you can connect things to generally. And so that is our general purpose input-output. It's for any communication that you want to do, anything you want the board to talk to, any sensors, any attachments, they will go through GPIO pins almost all of the time. And that's what we use on our controller board here for the controls we're doing. So, for example, we have the throttle control coming in for which way are we going and how fast are we going. That hooks up to a GPIO pin. We also have the horn control. Also, GPIO. Both of those are the input side of GPIO. They're flowing into the board. They are different signals, however. There are 2 main signals for GPIO. There's digital signals coming in either on or off, 1 or 0, or analog signals coming in over a range of values. So just like Kevin mentioned, if we have a potentiometer that scales a voltage, it comes in over a range of voltages, and the board can read those voltages and do different things depending on the different levels. Or the horn, which is just on or off. We're either going to honk the horn or we're not. The way that those two hook up is just plugging, in this case, right into the board, and the board reads those voltage numbers out. It can also turn the horn on or off. So that's the output side of the GPIO. And it does that by simply powering the pin on the board or grounding the pin on the board. So it's either going to send out a signal at a certain voltage, usually 5 volts, sometimes 3.3, or it's going to send out ground signal, pulling the whole circuit down to ground. The other control piece that's on this panel, as you may have noticed, is the actual key for the ignition. That one in this project does not actually go to the GPIO pins on our controller board. That one is just what is sometimes known as a hard switch or a kill switch. It regulates the board. It sends its signal by, instead of sending signal, simply letting power through or not. It's just a simple switch. So when the scooter is in the off position, when the key is turned to off, it's not letting any of the voltage through from the battery, so nothing is being powered and nothing turns on. Or when it's in the engaged position, it turns on, it connects its circuit and its switch, and it lets power flow to all of the other components on the board. All of the other sensors, switches, the control board itself, all are powered when the switch only goes to on. But we otherwise don't need the signal from it, so we don't actually hook it up to the GPIO pins on our controller board. So those are a couple of the simple concepts that you may have found, may have used in simple hookup projects or getting started projects with different boards or different sensors. And the same concepts come and apply right to more complicated or more fun or full-featured projects when we talk about making a whole scooter.
Okay, so that is practical application of some of these things. Like I said before, there's a lot of getting started tutorials where you're hooking stuff up on breadboards, and that's interesting and exciting at first, but I love to see that transfer into real-world applications where instead of just some random part that you got in a kit, you're like, oh, that knob's a potentiometer. I know what to do with that. I know how to hook it up to my platform. So that's what we're going to be doing next. Next up on this project is we've got everything pulled out. We've got the control board out where all those signals run into, the factory version of the control board. And we're going to look at taking that apart, seeing what's actually inside, and replacing that with our own version of a control board.
Okay, that does it for this episode of Daily IoT. I appreciate everybody watching. Again, if you could take just 2 seconds to go down into the comments and give a shout out, thumbs up, thumbs down, any kind of feedback, I would just love to hear from you. Just let me know that you're out there. I really feed off of that. Otherwise, until next time, I appreciate you watching Daily IoT, the show where together we're learning all about the Internet of Things, one day at a time.